So what I want to do today is really talk to you about partial fractions. Now you can see in that problem that was presented by Margaret that really we needed to express that function in terms of partial fractions so that we could effectively use some tables to actually go from the S domain back into the time domain. So look, I thought it would be useful then for us to have a bit of a discussion in this topic area of partial fractions. So look, let's supposing that we have two fractions. We're going to say we have a 2 divided by x plus 4. That's one of them. And then we've got a 5, and we're going to say that that guy is divided by 3x minus 1. All right. So let's add these guys together. All right. So what would we have? We'd have a 2, and this would be x plus 4. And that is plus the 5 divided by the 3x minus 1. Okay. So let's see now, can we find a common denominator here? Yes, well, standard technique for doing that. Our common denominator then, we would say, is what? It's going to be x plus 4, bracket, multiplied by 3x minus 1. What do we have in the numerator? Well, in the numerator we would have a 2, and this would be multiplied by 3x minus 1, and then we would have a plus the 5, and that's multiplied by the x plus 4. Okay, and I think if you take a moment here and you sort of divide this term here by x plus 4 multiplied by the 3x minus 1, and then you took this term here and divided by the same, you would get this result over here. Okay, so look, let's take this just a little bit further. So we're going to say, look, we've got our 2 divided by the x plus 4 plus the 5 divided by the 3x minus 1, and that is equal to, so what are we going to do here? We're going to multiply this out. So that's what? That's 6x, and then 2 times the minus 1 is a minus 2, and then we've got what? 5x, so that's a plus 5x, and then we've got a what? 5 times 4, which is a plus 20, and of course this is still divided by what we have in the denominator here of the x plus 4 and the 3x minus 1. Okay? So what can we do now? We can collect our terms together. So we'll just take this really one more step and collect our terms together. So we have what? We have a 2 divided by, this is the x plus 4, plus we have our 5, and that's divided by the 3x minus 1, and that is equal to what? Well, how many x's do we have? We've got 6x and 5x, so that's 11x, and then minus 2 plus 20, so that's what? A plus 18, and that is divided by the x plus 4 multiplied by the 3x minus 1. Okay? All right, so these guys here are what we'll represent as our partial fractions. So let me just describe that. These guys right here and here we're saying are really our partial fractions. Okay. And so what we're saying is if we have an expression that looks like this, can we actually go backwards and determine what our partial fractions are? And look, in many problems, it really is easier to deal with the partial fractions. This could be true from an integration point of view. Integrating this is easier than integrating this guy over here. And it's also true from a Laplace transform point of view, especially taking the inverse transform to get back to the time domain. All right, let's take an example here. So we've got this expression, and what we want to do is we want to represent it in a partial fraction form. So how do we do this? Well, we're going to take this expression, which is 10x, and that's divided by, we've got x plus 4, we've got 2x plus 3, we've got an x minus 1, okay? So there we go. And we're going to say that is equal to, well, it's going to be equal to a constant a, divided by, so these are the partial fractions, so this is divided by the x plus 4, plus b, that's going to be divided by the 2x plus 3, plus c, another constant, and that's divided by the x minus 1. Okay, and our task is really to be able to find a, b, and c. All right, so let's see if we can work with this just a little bit here. So we're going to say, looking at this, we're going to say we have what? We have 10x is going to be equal to, all right? So really, what are we doing here? We're going to multiply both sides by what is in the denominator here, all right? So we're left with 10x on this side. Over this side, we're going to have what? We're going to have an a, and that is going to be multiplied by what? It's going to be multiplied by 2x plus 3 times the x minus 1, okay? Plus b, and that's going to be multiplied by the x plus 4 multiplied by the x minus 1. And then we've got a plus c, which is multiplied by the x plus 4 and the 2x plus 3. All right, so that's what we've got. Now we're really in a position that we can start to think about how we find these constants, okay? So that's our task, is really to find a, b, and c. All right, so how are we going to do this? Well, let's see if we can find a first. So what we're going to do here is going to look for a value of x that makes these other two terms equal to 0. So what do you think that x might be? Well, look here, there's an x plus 4 here, there's an x plus 4 over here. So what if I said to you that I make x equal to a minus 4, and I put this information in, right? If x is equal to a minus 4, and I put it into this term here, then this is a 0, isn't it? And it's a 0 here. So this and this are gone, and we're just left with this. So let's do this. So we've got what? We've got a 10, and that's going to be x multiplied by minus 4. That is equal to what? That is an a. Let's open up a bracket here. What have I got here in this particular bracket? I've got, I'll open up another bracket. I've got a 2, and it's times the x, which is a minus 4, plus the 3. Close that bracket. Then I've got what? The next x, which of course is a minus 4, minus 1. Close that bracket over there. All right, so all we've got to do now is really just kind of work this out. So what have we got over here? Well, we've got a minus 40, haven't we? Yes. And that is equal to what? A. Yes. Open up our big bracket over here. What have we got in here? Well, let's have a look at this. This is a 2 times a 4, which is 8. That's a minus 8 plus a 3. So that's really what? A minus 5. And that is times this guy over here. So that's a multiplied by this guy, minus 4 minus 1, which is also a minus 5. All right? And so therefore, what can we say? We can say that minus 40 then is really equal to a, minus times a minus gives me a plus, so that's a 25. And so therefore, I can say that a is really equal to a minus 1.6. I've got my first constant. Let's now find b. Okay, so I've got to think about these two terms here. I want to zero these guys out, here and here. So let's look at this. What do we have that's common here and common over here? Well, it looks as though we've got 2x plus 3, 2x plus 3. So we want to make that 0. So let's do that. So 2x plus 3, we want that to be equal to 0. So what's the value of x? X then is going to be equal to, you take the 3 to the other side, that's a minus 3, and of course that's divided by 2. So that's what we've got to put into this expression. That will zero this term over here, allow us then to calculate b. So we've got 10, and that is multiplied by what? A minus 3 over 2, and that is equal to b, okay, open up a big bracket here, put the x value in, x is what? Is a minus 3 over 2 plus a 4. Close that bracket. Then I've got a what? A minus 3 upon 2 minus a 1. And I'm closing my brackets. Okay. So that's kind of where I sit at the moment. So, therefore, let's take this just a step further. This would evaluate to be what? It would be a minus 15, wouldn't it? So that's a minus 15, okay, is equal to, let's evaluate this bit over here. So b, open up my big bracket. Evaluating this term here, what do I have? Well, I have a 2.5, and then that's multiplied by evaluating this. I have really a minus 2.5, closing the brackets. Okay, so therefore I can say minus 15 is really equal to a minus b times 6.25. And so therefore my b would be equal to a 2.4. All right, so that's evaluated this constant over here. Now what I need to do is really evaluate this c. So I really want to choose a value of x that really makes this term 0 and this term 0 over here. So what would that value of x be? Well, I've got an x minus 1 in this term, x minus 1 in this term. So if I made x equal to a 1, this would 0 and this would 0. So that's what we'll do. We'll say x is equal to a 1. Okay, so therefore we have what? We have 10 times 1, which is just 10, and that's going to be equal to this term over here, which is a c. Let's open up a bracket here. And we've got what? That's a 1, isn't it? Yes, because x is a 1. So that's really, I can do this. That's a 1 plus a 4, which is what? Really a 5, isn't it? And that's going to be multiplied by, well, what is that? That's 2 plus a 3, which is really also a 5. Okay? And so therefore, I can now say that my c would be equal to, just evaluating this, my c would be equal to, what is it, a 10 divided by 25, and so therefore c is really equal to a 0.4. So I can now say that 10x, which is back to the original statement, over x plus 4 multiplied by 2x plus 3 multiplied by an x minus 1 is equal to minus 1.6 divided by my x plus 4 plus 2.4 divided by my 2x plus 3 plus 0.4 divided by the x minus 1. And so therefore I have taken this expression, I've converted it to its partial fraction form, which is this over here.